A reduction-oxidation redox reaction always involves two events. One substance loses electrons and is said to be oxidized, while another substance gains electrons and is said to be reduced. Sodium chloride, or table salt, offers an example of atoms that have undergone oxidation and reduction to become ions. When sodium and chlorine react to form sodium chloride, one electron is completely transferred from the sodium atom to the chlorine atom. The result is a sodium cation and a chloride anion. In this redox reaction, the sodium atom lost an electron. It was oxidized. The new sodium ion is a positively charged cation. The chlorine atom gained an electron. It was reduced. The new chloride ion is a negatively charged anion. In redox reactions, electrons can be transferred completely from one molecule or atom to another, forming an ionic bond, or they can simply shift positions in covalent bonds. The combustion of methane is a good example of this second type of reaction. The electrons in the two reactants, methane and oxygen, are shown as dots at equal distance from the atom's nuclei, indicating that electrons are shared equally. When electrons are shared equally, the bonds are nonpolar. Methane combustion involves the reaction of two oxygen molecules with each methane molecule. The reaction yields carbon dioxide and water as the products. The atoms in the product share electrons unequally, meaning that the bonds are polar. In carbon dioxide, the nucleus of the carbon atom holds the electrons less tightly. Carbon has been oxidized. It lost electrons. In water, the nucleus of the oxygen atom holds the electrons more tightly. Oxygen has been reduced. It gained electrons. Because the atomic nuclei of the product molecules hold the electrons more tightly than they were held in the reactant molecules, the products have lower potential energy. Such reactions tend to be spontaneous or exergonic and release free energy.